Okay, so everybody calculus. I combined some of the main important notes from 4.6 to 5.2 all together because 4.6 there's a part where it talks about Simpson's rule that you all don't need for the exam. You wouldn't have needed for the exam period. So it talks about the trapezoidal rule, but I feel like the way it explains it is just as complicated as the way the book tries to explain Riemann sums. So I'm going to show you the trapezoid rule with some actual examples of how it'll show up on the exam later on in like the fourth video probably. So I'll show you that. 5.1 you kind of already know because of the topic videos I sent you. So it talks about e to the x and talks about natural log. So you need to read 5.1, but you kind of already know some of the stuff with it already. And then 5.2 is actually practice problems in doing natural log intervals and derivatives. So we're going to look at that. You're only going to have homework from 5.2, but you do need to read 5.1. And then I would read 5.2 and then you'll have the homework problems. So for 5.2, key takeaways notes-wise is the derivative of the natural log is 1 over x. The derivative of the natural log with u, so if it has a function inside of it, you have to do chain rule, so it's going to be 1 over u, so 1 over whatever's in here, and then you take the derivative of that, so u prime. Okay, and then the antiderivatives, so if you take the antiderivative of 1 over x dx, you get the natural log of x plus c, and then the antiderivative of 1 over u is the natural log of u plus c. This only works because of that du, and I'm going to explain that in a little bit. Okay, so let's look at example 1. So you have the integral of 5 over x dx. So the 5 is just a coefficient, it's just a number, so you can move it to the outside of your integral. So you have 5 times the integral of 1 over x dx. So the antiderivative of 1 over x dx is natural log, so it's going to be 5 times the natural log of x plus c. And then if you wanted to simplify more with log rules, you don't have to do this, but I'm sure it'll show up at some point. Whenever you have a logarithm and a number in the front, it actually can be rewritten as the exponent for the variable. So that 5 can move over here if you want to. I usually leave it like this. Okay, so example 2. You've got the integral of 1 over 2x plus 3 dx. So if we let u equals 2x plus 3, then take the derivative of that. So du would be 2 dx. So there's no 2 up here. So we're going to divide by 2. So you get 1/2 du equals dx, and now we can replace that 1 dx. So it's going to be the antiderivative of 1 over u times 1/2 du, because it's 1 dx is 1/2 du. Remember, we can move the 1/2 to the outside of our integral because it's just a numerical coefficient. And then we have 1 over u du. So the antiderivative of 1 over u du is just the natural log of u. So you have 1/2 times natural log of u plus c, and then you go back in and replace your u, which was 2x plus 3 for this problem. Don't forget your plus c because these are general antiderivatives.